let's continue on here. Just with those first 7 questions, we'll put a note of the wind direction, make a note of the wind direction of the 500 millibar. Winds are dictating directional movement of the surface. Well, down here, if you'll look at, we'll go back to our winds here at 18,000. So where should this low pressure system go? Okay, so here we are at the surface with the low just over Buffalo, New York, and where's it headed? Okay, well, based on the winds, it should be pushed up this direction. Okay, they're kind of changing. They curve westerly at this direction, but if we go back to our prog chart and look at the location of this front currently, okay, well, it should be pushed somewhat this direction. And if we go to our 12-hour, well, sure enough, that's exactly what happened. We got pushed from southwesterly winds. And anyway, there's cause and effect to this. I mean, some of it certainly caused some of its effect from the winds at the 500 millibar level, but that's sufficient for you to see what's happening. Okay, so as far as I'm concerned, if you wanted to put noted on here, that is sufficient. I just want you to be aware of that. Okay. So moving down, we're about a fifth of the way through. What are the temperatures like in front of, around, and behind the front? What kind of visibility is along each front? Okay. We can answer these both. My favorite tool for this is the Java tools, and we'll use the large METAR version. Now, the reason I want to use this is because it's a nice depiction of the weather that's happening. We're probably not going to see a whole lot of temperature variation on each side of this little station area that's extending out of Canada, but we will certainly see some variations ahead of and behind this cold front here. This can sometimes take a minute to load, but you'll see in a second why I like to use this. We're going to be able to isolate, to look at temperatures, visibility. We can do wind as well, ceiling, so that we can answer these questions fairly quickly. On this particular chart, make sure that when you do this, you select the correct number of METARs. And mine's taking a little longer than normal to load, but when we go down here, this is probably not enough. We don't have enough station information here. This is spread too far out, so we're going to go to more under the Show METARs data at the bottom. We'll go from the default to more stations. And as we zoom in, this will probably help us to have enough data. Here's that stationary front. Very little in the way of temperature difference here. As you kind of look, one of the other problems you're going to have in this area of the country is the weather stations are very few and far between. If I had to say, it looks to me like there's a spread. You know, here we've got 44 degrees, and this is in Fahrenheit. Obviously, looks like west of that station area we're, in this case 48. On this one, I don't want you to stress too much. Stationary front, we're going to go back over. That's fine for this one. Okay, let's go over on the eastern seaboard now. Okay, now looking at this area, let's zoom in and take a look at what these temperatures are ahead and behind. Okay, now here we can already see some dramatic differences. Okay, let's just zoom in, on this area right here, and I'm going to zoom in here. We can see where that front is. Okay, all these winds out of the southwest or south, and then northwest behind. So here's where that front's coming through. We also have some precip differences and the temperature differences ahead of and behind the front. If we look across this latitude area, we've got 60 to 70 degrees, and then we're in the 40s. This is over the mountains though, so we got to be careful there, but we're basically, you can see the temperature differences. It's about a 20-degree spread with this front, and I would put probably averages 15 to 20 degrees across this front. So cold front, temperature drops 15 to 20 Fahrenheit from ahead to behind the front. Now that's even verbose. If you just tell me the temperature drops 15 to 20, with the cold front, I get, I understand that it's behind the front, that it's going to be cooler. But this is really a great tool for you to be able to actually visualize what's happening ahead and behind the front. We can see precip behind the front. We can see the temperature drop. If we go into Pennsylvania, we can see some dramatic differences in the 50s, really, along the seaboard, and then we get down into the low 40s and even the 30s. That's pretty dramatic. This is exactly what I want you to see. Okay, what kind of visibility is found along each front? Well, let's go down to the bottom here where we can select, and let's just look at visibility only. We'll select the METAR data options just to be visibility only. Okay, and as we do that, there we go. Okay, now this one's gonna be a little tougher to identify because the visibility typically clears up quite quickly behind the front, but we do get some lower visibilities right around the front itself. For the most part, though, it's looking pretty good. Now, when we get up near the low pressure center, the visibilities drop, but this really isn't much of a difference. I'm gonna, I would just probably put in here occasional reduced visibility to 5 miles. Okay, I don't really see anything too dramatic from the METAR right here on the southern portion of the front. Okay, now as we get up further, we're going to have to unzoom here. Go back. Let's see if we notice anything different as we look at the rest of the country here. Up in this portion, yeah, again, the visibilities are really only lower around that low pressure system, not a whole lot of dramatic difference. Okay, so there we go. Okay, the visibility, let's go back to that stationary front just for kicks, but my guess is we're not going to see a whole lot of difference, and there's not.